Hey, so welcome back, and this is another daily LeetCode problem. So today was yet again another graph algorithm, so let's get to it. So it's called longest cycle in a graph. And so what you're doing is you're given a graph like this one, and you want to see, okay, what is the longest cycle in this graph? So in this one, there's actually only one cycle, which kind of makes it pretty easy, but you want to return the length of the longest cycle. And so in this case, because it has a length of 3, you just return 3 here. And so just clarify, in case no one knows what a cycle is, so it's basically where you can get to a node a second time. So because this one is a directed graph, so you can't kind of go forwards and backwards, the only way you can kind of have a cycle is if you have like an outgoing edge, then also an incoming edge, and somehow those two nodes connect, and they do. And so you can kind of go from 2 to 4, back to 3, and back to 2, and 4, and you kind of do this infinitely. Okay, and so the length of this is 3 because you have 3 edges. All right, and so this example, you would actually want to return -1 because there is no cycle. So this is just a case of, okay, if you don't have a cycle in a graph, just return -1. And so let's look at maybe a better case, and this is the scenario I was thinking of. So let's say we have 0, and say then 1, and then 2, then 3, then 4, and they're all connected, like so. And then we have another connection all the way back to 1. Okay, and so this is the kind of, when I was solving this is what I was thinking of, kind of like the shape of a letter 6 almost. And so what you'd want to do is we would say, okay, does this have a cycle? And so although we started at 0, see we're kind of going down and then back up here, we need to kind of keep track of, okay, what have we visited before, not just kind of what did we start with. And so because we want to be able to detect this cycle further down in this graph, and so you need to kind of say, okay, we visited 0, we visited 1, 2, 3, then 4, then like we're visiting 1 again, and well, we already visited that right here. Okay, and so you need to kind of have like a visited set, which is half of it. I didn't kind of mention this before, but we'll be doing a depth first search on every node in this graph. And I believe I was watching Larry, who also does daily LeetCode problems, and he kind of coined this graph as a functional graph. And I think that's when it's just every single node has just one outgoing edge to another corresponding node. So I guess this type of graph. And so, yeah, so you want to keep track of what you visited, but then you also want to keep track of, okay, what is the depth of that particular node that you're looking at? And that is used so that you can calculate the length of that cycle. And so if we look at our case again, where it's like 0, 1, 2, 3, and then 4, so this one goes back to 1, and these are all kind of connected here. And so you'd want to say, okay, say we drilled down on 0, we would want to say, okay, this has a depth of 0, this 1 here has a depth of 1, this is a depth of 2, 3, 4, and then when we're circling back, this one will see, okay, this has a depth of 5, and you would say, oh, but we already visited it. So to get kind of the length of this cycle, you would just do 5 minus 1, which is 4. Okay, and so basically you compare, okay, I've already visited this, and this was the previous depth, but if I subtract that depth from the current depth, I kind of have the length of the cycle. And so you don't actually want to clear also your visited set. And so because we're going to be kind of doing a depth first search on every node, you still want to keep track of the nodes that you visited it previously in like a previous depth first search, because you can just return -1 in those cases because, well, if it already belongs to this particular cycle, you'll already have measured, if it is a cycle, the length of it previously, so you don't need to travel in that cycle, because no matter where you start in that cycle, the cycle is going to have the same length. And then also, okay, well, say you did a depth first search on a node and there was no cycle previously, then you could just return -1 because, well, in that case, we do want to be returning -1 for those where there is no -1 cycle. Okay, so that's the graph algorithm. We'll go ahead and implement it. In the worst case, like, you'll go down every node and every vertex, so it will be kind of like O of V plus E for vertexes and edges. But typically people say, okay, well, edges is equal to the number of vertices minus 1, because you'll only have, say, 1, 2, 3, 4, 5. Oh, well, actually there is 5 edges in this case. Anyways, I'm not sure what I just did wrong there. But basically, typically the number of vertexes, we'll have 1 edge for every vertex. And I believe that's because you only need, yeah, so this is because there's cycles. And so there can actually be more than V minus 1 edges. And so V minus 1 comes from, okay, you only need V minus 1 edges to make it connected, but we know that this could be more than connected because, excuse me, there'll be cycles. But we also know that, okay, there's not going to be more vertex or more edges than vertexes, because it's going to be a one-to-one relationship, given this kind of array representation of our graph. Excuse me. And so we can just say, okay, the time complexity is O of E then, or O of V, either if you're choosing, because it's one-to-one relationship. And then the space complexity, because we're going to have our visited set and we're doing like a depth first search and kind of drilling down on these, so our application tag is taking up room, and then we're going to need to keep track of like the depth that we're at for each one. That's also just going to be O of V or E, either you want to choose. So yeah, so that's the time and space complexity. So let's go ahead and implement this. I'm doing a depth first search, and we want to be iterating through our edges. So for every I in the length of our edges. And so from there we say, okay, we want to perform a depth first search on it. And so this will be returning the length of that cycle. And so you just want to say, okay, the max cycle is equal to the max of the existing max cycle and the result of our function. And so we'll want to be returning this result of that computation at the end. And initially, why don't we set the max cycle to -1, because we don't want to set it to 0 because we will always want it to return -1. So if we're comparing 0 and this is returning -1, then you'll still get 0. So you really want to start with -1 here. And we don't actually, usually for graph questions, you kind of have to make an adjacency list. But because each node only has one corresponding outgoing edge, you don't have to build that. But we still need to have our visit set and our, I'll call it depth. And so this will be an array that's kind of keeping track of the depth of a particular node. So at index 0, it's going to have the corresponding depth of that node. So the value for like node 0 will be kept at index 0, and that value will represent the depth that we calculated for that particular node in that depth first search that we're doing it on. Okay, so it's called a direct access array. And so we'll just say, okay, this is infinite initially, and we want to multiply that by the length of our edges. Great. And we can multiply by the length of our edges because that is the number of nodes that we'll have. So we want one for every node. Okay, and let's make our depth first search function. So what you want to do is say, okay, if this particular node that we're looking at is in visited, or it's equal to -1, then let's just return -1 in that case. And so you do actually have to handle cases of where, okay, this 1 has no outgoing edge, and so it has just a -1 here. Okay, so if there's no negative, like if the kind of depth first search ends, naturally there's no cycle, and so you just want to return -1 in that case. Then also, okay, if that node has already been visited before, we don't need to calculate the max cycle because we already know the length of the cycle. And then, okay, well, even the case where there was no cycle in it, you want to be returning -1 in that case. Okay, and so from here, what you want to do is we want to visit that node. So visit, and we want to add the node that we're looking at. And we'll want to perform a depth first search on that node. And so you want to say, okay, edges at that node, you would call that. And this would result in the resulting value, right, of that depth first search. And actually you want to visit after performing the whole depth first search because you don't want to mark it as visited before you've kind of gone down that tree, because the last thing you want is, okay, we visit 1, and then because we visited it, and as we're returning in the cycle, we don't want to be returning -1 because we just found a cycle. We want to return the value of that, the length of that cycle is. So you want to revisit after all the depth first search has been completed, and then you return the value. Okay, and so the last step that we need to do is calculate the length of that cycle, which is another base case. So what you want to do is say, okay, if the depth at this node n is less than the current depth, then you're going to want to return the current depth minus the previous depth that was found at that node. And so we want to be propagating the current depth that we're at. And initially it will be 0. And whenever we perform another depth first search and we're drilling down on kind of the children in that hierarchy, we want to be adding to our depth. And then finally, we just want to be, I believe, updating our depth at that node to the current depth each time. Okay, so this is handling the cases where, okay, remember that scenario where I showed you with like that 6 where it goes 0, 1, like 1, this is 1 here, 2, 3, and then back to 1. So this has a depth of 0, 1, 2, 3, and then when we loop back, we have the depth of 4. So you just do 4 minus 1 is equal to 3, and that would be the length of this cycle, which it is. It's 1, 2, 3 edges. Okay, and so this depth gets updated to the current depth that we calculated each time. We just increment it by 1 when we drill down on that node. And then this is another base case, and we kind of propagate it upwards, and we just update our max cycle with each iteration. Okay, so let's go ahead and run that. and success. So yeah, it's O of E space and O of E time, or O of V and O of V space, either of your choosing. But yeah, I hope that helped. It's a great question to practice depth first search. It is quite challenging to kind of come up with the solution. I think what makes it from a medium to a hard question is this hard question has this depth direct access array, while most medium problems you only kind of need to keep track of the visit node and just deal with parameters in your depth first search function. So yeah, I hope that helped, and good luck with the rest of your algorithms. Have a good day.